Hey there, science fans. Today we're diving into the fascinating world of chemistry to explore a process so important it underpins countless industries and products we use every single day. It's called the contact process, and it's how we make sulfuric acid. Sulfuric acid! You might have heard of it, it's some seriously strong stuff, but did you know that sulfuric acid is so essential that its production levels are often used as a measure of a nation's industrial strength? That's right, this powerful acid is a key ingredient in fertilizers, detergents, batteries, and so much more. It's even used to make other chemicals, so buckle up as we break down the contact process step by step. Learn why it's so important and discover how it impacts our daily lives. Get ready for some serious science. Now let's get down to business and define the contact process. In simple terms, it's a method for making sulfuric acid, or H2SO4, from sulfur. This process involves a series of carefully controlled reactions that take sulfur on an amazing journey, transforming it into one of the most important industrial chemicals on the planet. We'll dive deeper into each step later, but for now just remember that the contact process is all about turning sulfur into sulfuric acid through a series of clever chemical reactions. You might be thinking sulfuric acid. That sounds like some dangerous stuff I never encounter, but here's the thing. Sulfuric acid is everywhere. Don't worry, it's usually in a safe form and concentration, but take a look around your home and you'll find its fingerprints all over that car battery that starts your engine. Yup, it uses sulfuric acid. The fertilizer that helps your garden grow, you guessed it, sulfuric acid is involved. And what about those drain cleaners that blast through clogs? You got it. Sulfuric acid helps make them work. Even the production of plastics, dyes and medicines relies on this versatile acid. It's the unsung hero of countless products we use every day. Section 4, the contact process, step by step. Okay, science enthusiasts, let's break down the contact process into bite-sized pieces. Step 1, sulfur combustion. We start with good old sulfur, which is found naturally in volcanic areas and underground deposits. The first step involves burning sulfur in the presence of air. This creates sulfur dioxide, a gas with a sharp choking odor. Think of lighting a match. That's a small-scale example of sulfur combustion. S plus O2 gives SO2. Step 2, oxidation of SO2 to SO3. This step is where the contact in the contact process comes into play. The sulfur dioxide gas is mixed with excess air and passed over a catalyst, typically vanadium V oxide, at a high temperature, around 400 to 450 degrees Celsius. This catalyst speeds up the reaction, causing the sulfur dioxide to react with oxygen and form sulfur trioxide. 2SO2 plus O2 gives 2SO3 in the presence of V2O5 catalyst. Step 3, conversion to sulfuric acid. In the final step, the sulfur trioxide is dissolved in concentrated sulfuric acid to form a dense fuming liquid called oleum. SO3 plus H2SO4 gives H2S2O7. Why not dissolve SO3 directly in water to make sulfuric acid? Well, that would create a mist of sulfuric acid, which is difficult to handle. Instead, the oleum is carefully reacted with water to produce concentrated sulfuric acid. H2S2O7 plus H2O gives 2H2SO4. Section 5, equilibrium, a balancing act. Remember that double arrow in the equation for the oxidation of SO2 to SO3? That double arrow tells us that the reaction is reversible, meaning it can go in both directions. The reaction reaches a state of equilibrium. At equilibrium, the rate of the forward reaction, SO2 forming SO3, is equal to the rate of the reverse reaction, SO3 breaking down into SO2. This means that the concentrations of the reactants and products remain constant over time. Section 6, sulfuric acid, a chemical superstar. So there you have it, the contact process. It's a remarkable feat of chemical engineering that takes a readily available element like sulfur and transforms it into one of the most essential chemicals in the world. From fertilizers that nourish our crops to batteries that power our devices, sulfuric acid plays a vital role in our modern lives. And it's all thanks to the ingenious contact process, a testament to the power of chemistry to transform our world.